Okay, so today we're continuing with applying systems. We already started with the first two types, which were the first ones? The rate problem and the item problem, right? Today we're going to continue with mixture and digit problems. We're still on the same objective. I can solve real-world problems using systems of linear equations. We don't need a Freyer model. We don't need steps. We already have them. What I do need you guys to do is to stay focused throughout the process of the two that I'm going to present today. Okay, here he goes. With that said, we already know what systems are. We don't need this. We already know our process, right? Read it twice, label stuff, use a table, get variables involved, read the problem, get equations, solve, and then check at the end. We did some of these with items, with more items. We did with airplanes. We did with canoes and such. And we arrived to this next one. Copy this one down, please. Example number 6. It says, a chemist mixes a 20% saline solution and a 40% saline solution to get 60 milliliters of the 25% saline solution. How many milliliters of each saline solution should the chemist use in the mixture? Copy that, please. All right, pens down, eyes up here. I'm going to go through the entire process to make sure that you understand this from the beginning. Here it goes. A chemist mixes 20% saline solution and 40% saline solution to get 60 milliliters of saline solution, which is 25%. How many milliliters of each saline solution should the chemist use in the mixture? So at the end, we need to come up with what? Milliliters. And here, the only milliliters that they give us is a total. They don't give us any for the first or the second mixture. Now, some of you are saying, Mr. Hugh, why don't they just mix this plus that and it should give us the same thing, right? It's the same kind of solution. Well, no. Remember that there's certain chemicals, they could be the same type, but they have different strengths. For example, let me put it in simple terms. I drink orange juice at home, but my orange juice is fresh orange juice. We buy like 2 sacks of orange juice, we juice those, and they make about a half a gallon of juice. I don't add water, and I don't add anything else. The juice that you buy at the store, orange juice, for those of you that have it in your fridge, it goes through a process of pasteurization. What is that? They clean out the liquid. Not only that, many times they add vitamins, vitamin C, or they add something else, like an acid to it. Why? Because they want it to last a while as it stays on the shelf. So therefore, are you drinking fresh juice? No. Am I drinking fresh juice? Yes. But they're both orange juice. So if I get 20% of this one, of the one you have in the fridge, plus the one that I have in the fridge, and we mix it together, it becomes a third type of orange juice, right? Because it has a little bit of this and a little bit of that. It's the same idea as this. Are we there? So here we go. So first off, we read it twice. Now we need to circle stuff. Here we go. First thing that catches my attention are all the percentages. Do you guys see all of the percentages? So let's box all those. 20%, 40%, and 25%. So we box those. Oh, okay, my bad. So there it is. And let's see. What else catches my attention? The 60 milliliters. 60 milliliters catches my attention. And let's see, it says a chemist mixes 20% of saline solution, box saline solution. But notice here they say 20%. Do we know how many milliliters here? No. So that means that's what we need to get at the end. So here I'm going to label this one first, because that's the first mixture. Then I'm going to go over here to this one, box this one. This is my second mixture. And that gives me a total of 60 milliliters, which is 25%. So what is it that they're asking at the end? How many milliliters of each saline solution? And how many mixtures did we have? 2, the first and the second. Everybody with me so far? So with that said, let's make our table. And the table, does it change? No. It's 3 lines down. 1, 2, 3, 2 across. There it is. Are we there so far? Yes. Okay. So now, do you guys notice on this one, this is not a rate problem, right? So therefore, if it's not a rate problem, it has to be an item problem. If it's an item problem, then therefore, what do we write here? Total. Okay. Now check this out. On the item problems, what did we write on the first line? Wasn't it cost? But does this one have cost? What does it have? So we're going to write percent. And in parentheses, write decimal. We need to convert that into a decimal. Are we there so far? On the second line, we usually write item. Is that correct? Yes. But what kind of item are they talking about here? Saline solution. And for the second one, we're going to focus on the measure. What kind of measure are they talking about? Milliliters. So you're going to write ml. You're going to write ml for milliliters. Are we there so far? Yes. All right, so let's start organizing ourselves. Here we go. This column will be for my first mixture. This column will be for my second mixture. And before I translate those into percents, what was my first mixture? Do they give us milliliters? No, but they give us 20%. I'm going to label this one 20%. Therefore, the second one is what? 40%. And the last one is 25%. Are we there so far? All right, so let's see. How can we write 20% as a decimal? 0.20. How about 40%? 0.40. So now, check this out. 0.20 and 0.40. How can we distinguish that this is the first one and this is the second one? Unless we label it, right? So what can we label this one? X, very good. How about this one? Y. Okay. Now check this out. So it says 20% of saline solution. They didn't give us the milliliters. That's why we wrote 20% of certain amount of milliliters. This one is 40% of certain amount of milliliters. We don't know how many, right? This one, how much is the percent? 25 times 0.25. Do we know how many milliliters? 60, yeah. On this one we do know. 60 milliliters of 25%. So that means, let's multiply this to see what that gives us. 0.25 times 60. Do the computation, please. See what you get. Here we go. I heard 15. Is that correct? Yes. Okay. All right. Here we go. Next. Let's do the next item. Did we know how many milliliters were the first mixture? Let's see. Do they give us milliliters on the first mixture? No. Therefore, we label it X. Do they give us the milliliters for the second? For the second? No. So this is Y. And what is the total milliliters? 60. So, at that point, we write our two equations. 0.20x plus 0.40y equals 15. And the second one, x plus y equals 60. So, at that point, I'm going to eliminate one of the variables. Okay, let's eliminate x. To eliminate x, what do we need to multiply the second equation by? Negative 0.20. So if we distribute, that becomes negative 0.20x, negative 0.20y equals negative 12. So at that point, we're going to eliminate. Let's see. This cancels this. 0.40 minus 0.20, that's 0.20y equals 15 minus 12, that's 3. Are we there so far? Okay, let's solve for y. Divide by 0.20 both sides. Divide by 0.20. Divide by 0.20. Y equals, let's see, 3 divided by 0.20. Move the decimal twice, add 2 zeros. So 20 goes in here once, 20, subtract 0, my bad. 10, 0, that's 5. So therefore, the first mixture has, the second mixture has 15 milliliters. Okay? Are we there? Because isn't that what we're supposed to get at the end? Milliliters? Yes. Next, I'm going to use my second equation again. X plus y equals 60. But instead of y, what am I substituting? 15. We got x plus 15 equals 60. Subtract 15, subtract 15. X equals 45 milliliters. Okay? Let's write our statement. Focus on the statement, guys. Let's see. Did we get milliliters for the first mixture? Yes. For the second mixture? Yes. When we write our statement, make sure we refer to which percent corresponds to which. So check this out. The chemist mixes 45 milliliters of 20% saline solution, comma, and, give me a second, 15 milliliters of how much? 40% saline solution to get a total of 60 milliliters of, what was the percent for the total? 25% saline solution. 10Q. Okay, so for this next one, I'm not going to give you another mixture yet. I'm going to go to the next type of problem, so like that at least we cover that completely. Then I'll come back to a mixture problem so that you guys can practice one here. Okay, here we go. Copy this next one. Here we go. Example number 8. It says, the sum of two digits of a two-digit number is 10. When the digits are reversed, the new number is 54 more than the original number. What is the original number? Copy that, please. So let me reread the problem again. It says, the sum of the digits of a two-digit number is 10. when the digits are reversed, the new number is 54 more than the original number. What is the original number? Are we there so far? Okay. Some of you are like, kind of sinks in, but not quite, so that you have an idea what we're talking about. When they're talking about a two-digit number, I'm going to think of a two-digit number, and I'm going to say 23. So that's a two-digit number, right? And the 2 is on the 10th digit, the 3 is on the 1st digit. Here, let me show you really quick, in case you don't see it. 23 is a two-digit number. 1 digit, 2 digit. This digit is on the tens. This digit is on the ones, or what we call units. Are we there so far? You're saying units, what do you mean? Well, yeah, how many ones do you see here? 3. How many tens do you see here? 2. That's why these are tens, these are units. Okay? So with that said, now that we read it, let's go back and circle stuff. Here it goes. Important thing to see on the very beginning, sum. Sum of what? 2 digits. 2 digits. And what does that give us? Is 10. Is means equals to 10. Are we there so far? Okay. Now let me go back with blue and underline the next part. Digits reversed. That means they get that number, they switch it, and the new number is 54 more than the original number. So this is going to be one of those that really need to understand what we're looking at, okay? So here we go. So once again, to get started, we already read it twice, we underlined stuff, now let's get a table going. Here we go. 3 lines down. 1, 2, 3, 2 across. There it is. All right. And by looking at this problem, is this a rate problem? No, this is a item problem. That's why we're going to label this top right total. No, I know, but what I'm saying is that so that you can see how even though it's a digit problem, it requires a different setup, but I'm just trying to let you know that it's not a rate problem. Is that correct? That means we're not going to write rate times time equals distance. Okay? Therefore, for the item problem types, what did we write here on the second one? I mean on the first one, cost. Remember that? But do they give us cost here? No. Do they give us percent? No. This one they give us 2 numbers, an original number and a new number. Don't they give us 2 numbers here? So here, this one will be for the original number. And this last one would be for our new number. So now let's see. We talked about a 2-digit number. And what places did we have? We have the tens place and we have the units place. Or in other words, the ones. All right, so let's see. The sum of a 2-digit, what does sum mean? Add. And the word is means equal, okay? So same thing here for the new one. Add and equal. All right, so let's see. Do we know our original 2-digit number? Do they tell us what number it is? Let's see. It says the sum of the digits of a 2-digit number. Did they tell you which one it was? No. Therefore, but we do know that it has to have tens and it has to have one. So what can we label tens? T for tens and U for units. And once you add those 2 digits, what does that equal to? 10. Isn't that equal to 10? Yes. Okay. So now let's see. Follow along. Now, from there, it says the digits are reversed. That means I'm bringing the U to this spot and the T to that spot, right? Because they're reversed, right? Okay. So this becomes U, but then isn't it in the tens digit? So how can we make it so that we know that it's in the tens digit? 10U. Because it says that the digits are reversed. So this one and this one we know by looking at it, it's already what? Tens. Are we there? You see how we reverse them? Yes. Because the units, we're placing it in the tens digit. Yeah, something like that. But there's only certain placements, right? Units, tens, hundreds, thousands, right? And right now we're in the tens. Since we're reversing it to make sure that we know that this is in the tens, we just write 10U. Okay. However, look at this one. We know that T stands for what? And if it's in the units, that means it's 10, right? It's only 110, right? All right. Whew. So what does that equal to? Let's see. When the digits are reversed, the new number is 54 more than the original. So let's see. The new number is 54 more than the original. What was the original? This is the original, but since I'm going to write it in this format, I'm going to write 10T plus U. And how many more? 54. Plus 54. I know this is a little bit confusing. That's why you need to figure out, you need to set up the first one like this and see how the second one sets up by using the tens because they reverse a lot of the stuff that they're talking about. Okay, here we go. So let's write our equations. Our first equation is what? T plus U equals 10. Our second equation is 10U plus T equals 10T plus U plus 54. Are we there so far? Yes. All right, so before we start eliminating stuff or whatever, it needs to be simplified, doesn't it? This one, the second one, needs to look like this. So check this out. I'm gonna get the variables to this side of the equation. So what can I do here? Subtract 10T. Let's see. Subtract 10T, and I'm going to subtract U from this side. So whatever I do to one side, I do to the other. So it's subtract U, subtract 10T. Yeah, because they're in different order here. So therefore, these cancel. We're left with what? 9U minus 9T equals 54. Are we there so far? Okay. Now, at that point, everybody look up. I could bring, everybody look up, please. I could bring this one here and multiply times negative something or positive something to eliminate one of the variables. Or I can simplify this equation. Look at it. Isn't 9 the same as 9? And isn't this a factor of 9? So that means to simplify to lowest terms, can I divide by 9 the entire equation? What does that leave us? U minus T equals 6. Everybody see that?
No. Okay. Why don't you put the 9 and then...
You can. That's what I'm saying. You can go that route, but I'm trying to simplify as much as I can. So now check this out. Now I'm going to bring the first one over here. Which one goes under the U? U plus T equals 10. So let's see. So this becomes 2u equals 16. Divide by 2, divide by 2, u equals 8. So now, on the original number, the units is an 8, right? Now we need to figure out what the tens is, right? So which of these am I going to use? The one with the positive? This one. So u plus t equals 10. But instead of u, what goes here? 8. I bring down the plus t equals 10. Then at the end we subtract 8, t equals 2. So let's see what this says. Let's read the problem again. Here it goes. Everybody look up, please. The problem says, the sum of the digits of a two-digit number is 10. And we said that the original has a tens and it has a unit. So let's see. What's my tens digit? 2. And what is my ones digit? So my original number is what? 28. Everybody see that? But then it says, the digits are reversed and the new number is 54 more than the original. Well, let's see. Let's reverse them and see if it's true. I'm going to reverse them, and so our new number is 82. Is 82 54 more than 28? Let's see if that works. Let's see. Plus 54, that's 12. We got 1. 82. Yep, that is true. So we found our numbers. This is our original number. This is our new number. And what was the question? Let's see. The question was, what is the original number? So what would be our statement?
The original number is 28.
That's it. The original number is 28. 10 cubed. So now check this out. The one piece of information that we really need to look at. Everybody look up. Look at the table. The table starts off fairly simple, but you just need to make sure you understand that this is for the tens digit, this is for the units. And we write for the original, t plus u equals 10. Are we there?
Yeah.
For this one, for the new one, since we reversed them, the u goes here, but to understand that it's in the tens digit, that's where we wrote 10u. Plus, this one moved to this space, is equal to 54 more than the original. The original was 10, t plus u, but so that we write it in the same format, it's 10t plus u, and then we add 54. And that's how we end up here. T plus u equals 10, and tu plus t equals 10t plus u plus 54. And from there we said, before we eliminate, I'm going to simplify this one. So I got rid of the variables to this side. These cancel, brought down to 54. 10 minus 1, that's 9. Negative 10 plus 1, that's negative 9. And I said, let's simplify this equation by dividing by 9 each term. And that gives us u minus t equals 6. At that point, I brought this one down. And why didn't I write the t right here? Because it doesn't combine with that. What does it combine with? The t. The u, I wrote it under the u and equal to 10. U plus u equals 2u. These cancel. 6 plus 10, that's 16. Solve for u, divide by 2. So the units is 8. From there we got this equation. Substitute the units here. U plus t equals 10. Solve for t, and t equals 2. Therefore, in my original number, the tens digit is 2, and the units is 8. Yes. Stay behind. All right, let me, for homework. Homework is on page 359. It's not going to go to 360, and I want you to do numbers 2, 3. Have a seat, please. Have a seat. Have a seat. Everybody have a seat over here where you belong. 2, 3, 5, and 6. All these 4 problems are the same that we covered today. Okay? Keep homework from last night. You're going to turn it in tomorrow together with this one. Okay? Have a good one, everyone. See you guys in tutoring. If not, see you guys tomorrow. Oh, my bad. No tutoring today. My bad.